Hello and welcome to the Atmosphere Show. I'm your host, Olivia Bauer, along with Joanna Barrington and Grace Ann Green. Today's topic is the stratosphere, my personal favorite layer. With more on this topic, we go to Joanna and Grace Ann.
The stratosphere is a layer of the Earth's atmosphere. Stratosphere is the second layer as one moves upward from the Earth's surface. Of the atmosphere, the stratosphere is above the troposphere and below the mesosphere.
The stratosphere occurs at 50 kilometers high, or 31 miles. The boundary between the stratosphere and the mesosphere is called the stratopause. The altitude at the bottom of the stratosphere varies, with latitude and seasons occurring between 18 and 17 kilometers, or 5 to 10 miles. The bottom of the stratosphere is around 16 kilometers, or 10 miles long. Above Earth's surface, near the equator, around 10 kilometers, or 6 miles, at mid-latitudes, and around 8 kilometers, 5 miles, near the poles. It is slightly lower in the winter at mid and high latitudes, and slightly higher in the summer, The boundary between the stratosphere and the troposphere below is known as the stratopause.
An unusual type of oxygen molecule that is relatively abundant in the stratosphere. It absorbs ultraviolet radiation from the sun. By doing this, it keeps the stratosphere warm. As you get higher in the stratosphere, you also get much warmer.
This is the exact opposite of what happens in the troposphere. Here, temperatures drop with increasing altitude. Because of this, there is little convection, which marks clear layers in our atmosphere. Sometimes commercial jet airplanes fly in the lower stratosphere to avoid turbulence in the troposphere.
Here, the stratosphere is very dry and contains little moisture, so clouds are rare in this layer. There are a few, but they occur in the lower stratosphere because of the moist troposphere. Polar stratospheric clouds are PSCs are an expedition. PSCs appear near the poles during winter because the temperatures get down to negative 78 degrees. The air is so cold that it reaches its dew point in the stratosphere and forms the clouds known as PSCs. PSCs help form the infamous holes in the ozone by encouraging a chemical reaction that destroys ozone. PSCs are also known as Mercurius clouds.
Air is about 1,000 times thinner at the top of the stratosphere than it is at sea level. Use of this, jet aircraft and weather balloons reach their maximum altitudes within the stratosphere. Unfortunately, when particles get into the stratosphere, they tend to stay there for long periods of time.
Because of this, an ozone-destroying chemical called chlorofluorocarbons, or CFCs, get in. Large volcanic eruptions and meteorite impacts can fling aerosol particles up into the stratosphere where they stay for months or years. Rocket launches inject exhaust gases into the stratosphere, producing uncertain consequences. Different types of waves and tides in the atmosphere can influence the stratosphere. Some waves carry energy up from the troposphere into the stratosphere, while others move energy up into the mesosphere. The tides and waves influence the flows of air in the stratosphere.
A rare type of electric discharge that is kind of related to lightning that occurs in the stratosphere. These little jets appear above thunderstorms and extend from the bottom of the stratosphere 50 kilometers, which is still barely inside of the stratosphere.
Goodbye, everyone, and thanks for watching our show on the stratosphere. See you tomorrow when we talk about the mesosphere. Good night, everyone.